Hi everyone, and welcome to today's ARCHER2 webinar. Today's speaker is EPCC's William Lucas, who will be talking on the Hitchhiker's Guide to ARCHER2. If you have any questions, please feel free to put them in the chat, or after the talk, feel free to click the raise hand button and we'll see if we can answer all your questions. So yeah, without further ado, I'll hand over to William.
Hi, thanks Queveline for introducing me. Let me just quickly pop on my video so I can say hello to everyone. Oh, okay, hopefully you can see me, so I'll just wave hello there. Thanks for coming along to this talk just now. This is intended to be, if you will, a sort of crash course through everything for ARCHER2 if you haven't really used it before, or perhaps aren't that used to using HPC systems. This will hopefully not quite throw you in at the deep end, but get you through everything needed to get an account, log on the system, start building code, perhaps start running jobs. Okay, I'll stop my video just in the interest of saving my bandwidth from dying. I'll put some again at the end for questions so you can talk a bit more face to face, I guess. Okay, and with that, let's get going. Just to check, everyone can see the slides, can they? Great, thanks, Queveline. Okay, perfect, then let's get going with no further ado. So first of all, we just have a quick license slide here. So this is going to be shared under the Creative Commons Attribution Non-Commercial Share Alike, so you can share this onwards if you like, use it if you want for other things, as long as you continue to attribute us for it. And of course, the partners, there are a good few people involved in running ARCHER2. UKRI, the UK Research Councils, are people who fund it. It's run and hosted by EPCC at the University of Edinburgh, and of course, Hewlett-Packard Enterprise actually built it. So let's start off then by just asking, what is ARCHER2? So ARCHER2, you're probably aware, is a supercomputer. Specifically, it's an HP Cray EX supercomputer. This is a new model from HP Cray. Cray, of course, were a very well-known supercomputing company, bought recently by HPE. So HP Cray EX is the model. ARCHER2 itself is a service. It's the UK's national supercomputing service. That means that we are the top level, the largest research supercomputer in the UK for scientists to use for their research. And as I mentioned just before, it's physically hosted at EPCC, which is in the University of Edinburgh. For actual work, what does it consist of? What is the resource it provides? Well, its main resource is nearly 6,000 compute nodes. We'll talk a little about nodes and how the system fits together in a second. But just to get an idea of what it's capable of, it has 5,860 of these nodes. Each of these nodes has 2 processors on it, 2 AMD EPYC Rome processors, and each of those has 64 cores. It means each node has 128 cores, and across those nearly 6,000 nodes, that means we have 750,080 CPU compute cores. So all in all, you compare that to, say, your laptop, which maybe has 2, possibly 4 physical cores on it. That's pretty beefy. Beefy enough that in the last top 500 ranking of the most powerful computers in the world, it came in 22nd overall. Or if you consider just CPU-based systems, by this I mean systems which don't rely on accelerators like GPUs, for example, so just on CPUs, it comes in at 5th in the world. So it's a very capable system. What goes into making that very capable system? Well, ARCHER2 is a cluster. Basically, all supercomputers nowadays are built as clusters. This means that the system itself is made up of many small individual computers, which we're just going to call nodes. And the network links these individual computers together, and that turns them into a usable cluster. So it's many individual computers, remember, nearly 6,000 compute nodes, and the network linking them together allows them to communicate with one another, share work, and that turns it into a supercomputing cluster. Within the cluster, there are several types of nodes. We've got login nodes, which are the ones which you'll probably spend most of your time working on once you're on ARCHER2 doing things. There are 4 of those. We've got the nearly 6,000, as I mentioned, compute nodes. These are in 2 groups. One is a standard node, we call it, which just has 256 gigabytes of memory on it, 256 gigabytes of RAM. And then we have high memory nodes as well, which have 512 gigabytes. And on top of those 2, we also have 2 data analysis nodes. In terms of just doing compute, that's fine, but you also need somewhere to keep your data and keep your files. So we've got file systems to support that, file systems which can be accessed from across the cluster. We've got a home file system, which is 1 petabyte, just a network file system backed up. We've got a work file system that's much larger, 14.5 petabytes, and this is a special, what we call a luster file system. That means it's a high performance file system. It's specially designed for parallel access from the kinds of applications which you would be running on a supercomputer like ARCHER2. This is what we'll probably be doing all our work on, which is great because it matches the name, it makes sense. Finally, we've got some solid state storage. I'll talk about that in a second, but really this is something, it's there, but this is still up and coming for user usage. So I won't cover that really in this talk, but it's something to be aware of, that we do have solid state storage coming up for users to make use of, which could be really neat if you have, if you're intending to run applications which are perhaps strongly I/O limited. How does all of that fit together? So we've got all these nodes, this network, these file systems. What links it up? Well, you're going to log into ARCHER2 with SSH. So this is just something you'll run on the command line, perhaps, or from a program, or from an SSH client on Windows. We'll talk about this later. See, on one of the login nodes, you can see that on this image to the right. That gives you access to both the home and work file systems. So you'll be logging into the login nodes, you'll probably be doing work to set things up. Real work, so real supercomputing work, when you're running real simulations or post-processing, when you're doing the actual work, you'll be doing this instead, not on the login nodes, but either on the compute nodes or on the data analysis nodes. You don't directly access those when you log in. Remember, you just get on the login nodes, but you use those via what we call the Slurm batch system. Again, we'll be talking about how to use that later on. Something that's important to note, and this will come up a few times, and you can see it in the diagram, is that the work disk, the work file system, is what is available on the compute nodes. The home file system is not. So the home file system is really just what you'd put bits of code on, maybe some setup files, small pieces of small files which you don't need during a simulation, say, but things which you maybe just want to keep there. They'll be backed up on the home file system. But really, everything that you need for simulations will be going on the work file system. And as I mentioned, the solid state system is there. That'll be coming soon for people to use and have fun with. What goes into one of the compute nodes themselves? Well, I mentioned at the beginning they have 2 physical CPUs on them. We'll just say that this is socket 0 and socket 1. So into socket 0, we put one of the AMD EPYC Rome CPUs, and into socket 1, we put the other. Each of those has its own connection onto this Slingshot network. This is this special high-performance network in ARCHER2 to allow very fast throughput of data from CPUs and between nodes, between racks in the system, so to physically move data across the supercomputer. So each of those has its own connection onto that high performance network. Some of you won't care about this. For people who really do want to, who may be thinking about programming, who are doing application development or running perhaps OpenMP codes, this is more useful. So yeah, what's important here if you're in maybe those situations is to take note that each of those CPUs splits its 64 cores up into 4 different NUMA regions. So these are non-uniform memory access regions. And each of those is made up of 2 what they call compute complex dies containing 8 cores. So if you're running OpenMP in your work, you will probably want to be aware of this, because this means that you should be using either 2, 4, 8, or 16 threads per task. You don't really want to use more than 16 threads per task, because then those threads will be across different NUMA regions. 8 each core compute complex die also contains, so it's got 8 compute cores. They've got 256-bit AVX2 and FMA instructions available to them. Each core has 512 kilobytes of L2 cache, and there's also a 16 megabyte shared L3 cache on each of 2 4 compute complexes. So there are two of these compute complexes within each compute complex die. The terminology can get a little confusing here. For a lot of you, this won't matter. This is sort of too probably in depth for what you care about, but for some of you, this may be useful. So now I'll go on to passport control. So you see, I'm really leaning in here to the whole Hitchhikers guide thing, maybe from a slightly more pedestrian aspect than anything in the Hitchhiker's Guide to the Galaxy. But here's what I'll call passport control. So this is how do we get onto and use ARCHER2. So getting access, you'll find that basically everything to do with the admin side of working on ARCHER2 is done through the SAFE website. So the EPCC SAFE is a website. This is the link here. Those of you already on ARCHER2 will probably be acquainted with this quite well by now. Those of you may be looking to get access to ARCHER2 in the future, you'll become acquainted with it. So the first thing you'll do is create an account for yourself at this website. Once you're logged in, you can then use it to request an ARCHER2 account. To do that, you'll go to login accounts. It's a menu item on the top bar on the website. Then you'll just click on a button that says request login account. I should say that you may end up, depending on what your work is, who you're working with, you may end up with potentially many ARCHER2 login accounts, all on your one SAFE website account. And more than that, you may even end up with accounts on other machines run by EPCC also on there. So you'll end up with one SAFE account and potentially a good number of machine accounts. So actual SSH, actual accounts to SSH in with being administered through that one SAFE account. Once you're there actually requesting your login account, you'll need 2 things. One of them is the code for the project that you're joining. That will be provided by your PI, because every ARCHER2 login account is created under a project, under some piece of research, some work that's being done on the system. So you'll be, maybe a member of a grant or a project that's been given time on ARCHER2. That means that a project will have been set up on ARCHER2 for the users in that project to use, and you'll get a code that identifies all the people working in that project. So you'll be given this code probably by the project PI. So when you go to request your account, you can provide that, and that then identifies the account you're creating as belonging to that project. Something else you'll need is an SSH public key. I'll talk more about this next slide. This is to help authenticate you once you're logging in. Once you've made your account request, the project PI and any managers, so any people that the project PI is brought on to help administer the project, they will get an email saying person X, whoever that may be, has signed up, has asked for an account in your project. Go here to accept or deny that request. Assuming that they do request it, they do accept it, they'll go there and do that. You'll then get another email because once they've clicked on accept, everything else is automated. Your account will be created and you'll get an email saying it's been done. You can now log in. SSH keys can be a little tricky. I think this is a stumbling block to a decent number of people, and it is unfortunately a little tricky. These are just files used to help authenticate you when you log in. When you log into ARCHER2, you have to authenticate your login with both a password and an SSH key. So an SSH key is generated as a key pair that comes as a public key and a private key. The public key will go onto ARCHER2, onto the system itself. The public key will just stay, sorry, the private key will just stay on your computer, and it should never leave your computer. So that means you'll probably need to generate a key. Your system may have one there ready waiting for you, but you will probably need to generate one. If you're using Linux or Mac OS, or possibly if you're using Windows subsystem for Linux, you can generate a key pair with this command here, Ssh Keygen --key RSA means it should be RSA encrypted, and then C means it's going to get a your@email.com comment on the end to identify it. This will generate two files for you. It will generate your public key, which will have a .pub extension, and then also a private key without an extension, and they'll be created in the location that you provide while you're running this command. If you're on Windows, you'll probably be using, I would recommend Moba Xterm is a good SSH client to use. This comes with something called Moba Key Gen, just a little tool with it. You can use this to generate an RSA encrypted key. You just find it under the Tools button on Moba Xterm. It's fairly simple to do. You generate, again, a private key, which will come with a .ppk extension now on Windows. Again, this should just live on your computer and never go anywhere else. The public key you can also save to file, but the easiest thing to do when you're in the process of creating your account for ARCHER2 on the safe is to generate your key here in Moba Key Gen and basically highlight the public key, which you'll see in the window of Moba Key Gen. Just highlight it, copy it, and then paste it directly into the safe when it asks you for your public key. Once you've created your account, then because as I've said, your public key, your private key, sorry, should never leave your computer. If you want to then log in from a different computer, maybe from a laptop you have or a machine you have at your department, if you want to add extra logins, you can just create a new public-private SSH key pair on the new machine and upload the public key to the safe. Again, there's a little button to do that on your account. When it comes to physically logging in, as I said, you'll be using SSH to do this. So on Linux, Mac OS, Windows subsystem for Linux, you'll just use the SSH command on the command line on the terminal. You'll use your username that you chose at login.archer2.ac.uk. If you're just using the default name for the SSH private key, which is ID_RSA, that should probably be enough to let SSH detect that key and use it when you go to log in. If you're using a non-standard name for your key, or if it's in a non-standard location, so anything other than basically than what it suggests while you're creating the key, you may need to specify its name and location with this I-/path to private key information on top of that. Something else some people do, I do this myself, is I use the SSH agent. So I run this SSH-add command on the command line before logging in, and you just give it the path to the key, and you just do that every time that you either log into the machine new or turn it off and turn it on again. And that will ask you for the passphrase that you attach to the key, and then it will remember it, so you won't have to keep on entering it every time that you log into ARCHER2. Moba Extern is, I think, easiest and best on Windows, and this knows you'll have to specify the private key's name and location as part of setting up the SSH on that. So yeah, as I said, once you log in, you need to provide the key's passphrase and your account's password. I've italicized these because it's something you can, and an easy way to work out what it's asking you for, because you're essentially being asked for two passwords, it seems, is that whenever it uses the word passphrase, it's talking about the key's passphrase, and whenever it uses password, it's talking about your ARCHER2 account's password. The key passphrase is something which you choose while you're creating the key. If you're wondering what your initial account password is, you find that on the page, on your account page in the safe. So you just go to your to login accounts, and then your ARCHER2 account. Just click through to that, and then there's a button that says View Login Account Password. You can get that when you first log in. You'll then immediately, the first time that you log in, be asked to change it. It will say something like, you must change your password. You'll then have to enter the current password, the one that you got from the safe, again, one time, and then you'll be prompted to give your new one twice. Sometimes when it asks you here to enter the current password, it can give a slightly strange prompt. It might ask for something like LDAP password, just so you're aware. I'm going to use the Don't Panic title here, because I think this really is the first hurdle to using the system. It can be a little too easy, I think, to run into problems here, because this is all something which is set up. It can be very dependent on your computer and the way that things are set up on your computer. So if you do run into problems, basically you just need to work out what's going wrong. Why is your computer probably, because this is what happens most of the time, not able to provide the private key, and then work out how to get it to do that. There's a lot of stuff we have on the documentation. You can follow that through to the docs.archer2.ac.uk website. And if all else fails, the service desk is here. I think we're all pretty nice people. Please feel free to email us at this address here if you want help getting logged in. Okay, so let's go through to what you'll find on arrival, if you like. What will you find on logging in? You'll get a nice screen like this is the answer. You'll get some nice art to say, yep, you're here on ARCHER2. You'll be told something of interest here, hostname LN04, and you'll see that as well in the prompt at the bottom. That's my username there, wlucas at LN04. That means that we're on login node 04. Remember, when you log in, this is where you'll land on login node 01, 02, 03, or 04. And that's it, you can get to work. So ARCHER2 is a Linux system. It runs what's called the HP Cray Linux environment. That's based on SUSE Linux Enterprise Server version 15. Maybe you've used that, or you've used OpenSUSE, which is very similar to it before. You might notice some similarities if you look at the system software. And you'll find yourself in your home directory, which lives on the home file system. So that means you'll have a path through to your home directory, which is something like /home/ and then your project name, the same one that you provided to get to your account, / your project name again, and then / your username. So I'm in the Z19 project. So my home directory, where I'll land on login, is /home/ Z19 Z19 /wlucas. You'll have a parallel directory, I'll call it, because it's named almost the exact same thing on the work file system. So everything related to jobs, anything which you want to, any executables or libraries or input data or any other files needed during a job, during the real work that you intend to run, should go into your work directory, and you'll find that at /work, then project name, username. So my one is at /work/z19/z19/wlucas. Remember, everything should go in there for real jobs, because the compute nodes can only see this directory. Because it's Linux, you can then basically get to work using the standard Linux tool set to get going. You'll be LSing, CDing, making directories, CP, copy, MV to move. If you want to edit text files, there's Vim, there's Emacs, there's Nano, I think, as well. You can get to work using all of those to set up your simulations, to set up data, whatever you need to do to get going. If you haven't used an HPC system before, you might find the way that software is accessed on ARCHER2 a little different. Many supercomputing systems use what are called environment modules, because people logging in, different users will need to use very different software tools to do their work. So rather than just make everything available, which can make things a little tricky sometimes, we use environment modules to basically set up different pieces of software for you depending on what you need to do. So a module basically corresponds to one piece of software, although it may load other modules in turn, and you load a module to make that software available to you, and you unload that module to make it unavailable to you again if you want to do that. This might be a little weird. I've put a table here with some commands. I won't go through all of them, but we'll talk a little about over the next couple of slides and see some examples of how they can maybe be used. If you run module list on login, and I'll show you on the next slide what that looks like, you'll see which software modules are loaded at the moment. So what pieces of software are loaded and available for use right now. You can then use module avail to say, well, okay, what else can I load? What other software can I load to use at the moment? If you follow that up with an optional string, so just a word maybe, you can instead list any modules available to load now which contain that string. So maybe you want to use HDF5, say, you could do module avail HDF5, and it would then list to you all of the software modules available which contain HDF5 in their name. You then do module load, and then the name of a module to load that, to bring it into the environment, to make it available for you to use. Or you do module unload to get rid of it again. You can swap them with module swap commands. You say swap module 1, unload that, and in its place load module 2. And then there's a final command. I won't really go over it here, it's a little trickier, but you may need to know about it, is module spider. So if you can't see something which you think should be available with module avail, basically instead try using this slightly strange command, module spider, to search for it instead. The reason for this is that we use something called lmod. So there are different versions of environment module software out there. Lmod is the new one, which brings in something called hierarchical modules. Sometimes modules aren't available until you've loaded something else. So module spider will show you everything, even if you can't actually load it at the moment, and then it will show you how to make it available to load. That's a little tricky. You maybe don't need to worry about that one at the end, but the first three, I would say, are really what 95% of everyone does. They check out what modules they have loaded, they search for some, and then maybe they load some. Probably people log out before they unload or start swapping. So what's loaded at login? So this is just me fresh from logging in. I've done nothing else. Here I am still on login node 04. If I run module list, then the module commands will run, and it will just give me this output here, and it will tell me that I've got, well, these 13 currently loaded modules, which is actually quite a lot. If you've used maybe some other non-Cray HPC systems before, some other non-Cray clusters, you might log in and find that you have no modules loaded. HP Cray systems come with a lot of system software. A lot of it's tuned specifically for the hardware, and a lot of modules that support what they call a programming environment. We'll talk about that in a little bit. So there are a lot of modules loaded at login to help support this programming environment and to provide this extra software that's tuned for the hardware. So some of these you don't really need to worry about. In fact, I'd say probably of these you will never need to think about. A few there are of interest. So those would be things like Cray NPitch and Cray libsci. These ones might be of interest. So Cray NPitch is HP Cray's NPitch library. NPitch is an MPI implementation. So if you're running any kind of parallel program, it probably does use MPI. So this means that the version of MPI on the system, the one which you should be using in 99.9% of the time, unless you're using your own build of OpenMPI, say, or the like, you'll be using Cray NPitch, which is already loaded for you on login. Cray libsci is also there. Libsci is the special implementation of some fairly universal numerical libraries. BLAS and LAPACK and the like are included in that, provided by HP Cray for use on an HP Cray EX system like ARCHER2. A lot of them, though, a lot of these ones, the ones like Cray PE network OFI, say, these are lower level modules providing support software. Things they're mainly to do with helping the system use that special network which keeps things, which keeps the cluster connected. There are more HP Cray modules available. If you look through with Module Avail or Module Spider, you'll see that there are some libraries. We've got FFTW, HDF5, HP Cray provide those. There are some debugging tools, GDB for HPC, and more, as well as profiling tools. I'm not going to cover any of these just now. That's far more than we can go through in an hour. But these tools are all there. If you're on the system and you want to try using them, we cover them in the documentation for ARCHER2. Please take a look. I think they're pretty good. On top of that, the ARCHER2 CSE service, this is run by, well, I'm a member, so is Quiveen. We're at EPCC, and we provide more modules for you, the users, the scientists. So we provide some simulation software, things which are very commonly used by people, VASP, CASTEP, GROMACS, OpenFOAM, and more. We provide some tools like CDO and PowerView, and we provide some extra libraries like Boost and GSL. Again, if you run Module Avail or Module Spider, you'll see all of these listed. You can just module load them and get to work with them. Now, some people will be wanting to develop their own code and compile code and then run that on ARCHER2, but I think a lot of people also are what we just call package users. So people who don't necessarily want to do any code development, they just want to log on and start running simulations. People who have in mind exactly what they need to do already, they just need to get onto the system and start running things. So if you want to use centrally installed software, so CP2K, that's one of the simulation packages installed and supported by the CSE service at EPCC. That's a module. So if you run Module Avail, you'll see some CP2K modules there. So if you want to do that, you can just do module load CP2K. That will load the default CP2K module. If you take a look with Module Avail, you'll see there's a D next to it, which means that version 8.1 is the default. So you can just run module load CP2K, and then CP2K is there and ready for you to use. If when you're checking with Module Avail, you see there are different versions, you'll see they've always got the name of the module followed by a slash and then something else with the version. Then you can load anything that isn't default, or you can even just load the default module if you want to be more specific with the version by just including the full name of the module with that slash. So version 8.1 of CP2K is the default, but if you need to use version 8.2, then you would just do module load CP2K slash CP2K-8.2 to load that version instead. So this is, again, this is why having the modules available is really handy, because people will need different versions of things. They might need a particular version of a compiler. Say, if you use the environment modules, you can very quickly switch between different software at different versions, and it will set the environment up completely ready for you to use that. A lot of people I know use VASP. I think it is the most used software on ARCHER2. So if you want to use licensed software such as VASP, you can't just hop on, do a module load VASP, and then get going. First of all, you do need to provide your license information so that we know that you are allowed to use it. So to use any licensed software, CASTEP is more PyChem shell. Other examples, you need to request access to that through the safe. So you'd log in, you'd go to then login accounts, and then your username at ARCHER2 to get to your account page. You then click on the request access to package button, and then you choose which software you want to use, provide your license details, whatever they may be for the software in question. That will then create a query for us. We'll go and check your license, and then we might need to get back to you with questions, but assuming everything checks out okay, we can then approve your access to that software. We'll send you an email to say you're ready to go, and at that point you can hop back onto ARCHER2, do a module load VASP or whatever you want to use, and you'll be able to use it. People who do want to do programming on ARCHER2, this is where, again, these big sets of modules from HP Cray come into practice. HP Cray provides what are called programming environments for you to use. You'll see, if you remember back on the previous slides here, what's loaded at login, we've got a progenv cray /8.0.0 module loaded by default at login. That means that if we try to build software, we'll be using the HP Cray compilers as well as libraries built for those compilers. Something that might be a little strange if you've not used a Cray system before is that when you're building on an HP Cray system, you should always use what are called the compiler wrappers. So these will use the compiler that's set by the progenv module, as well as the correct support libraries built for those compilers. So by that I mean things like the correct version of libsci, which provides LAPACK and the like, remember, or FFTW or HDF5. So if you compile with the compiler wrappers, you'll be using this version, you'll be using these compilers, and you'll be using the libraries built for those compilers. So that means you can see the little table on the bottom left. If you're building Fortran, you wouldn't be using, say, gfortran or anything, you'd be using FTN. If you're building C code, you wouldn't use GCC, you would just use CC. But the modules will correctly make sure that once it is building, it will be using gfortran or GCC or the like if you want to use the GCC compilers. So as well as the HP Cray compilers, we've also got GNU and AMD compilers available. If you want to use those, the only thing that you change is the progenv module which you have loaded. You don't change the name. Remember, you always use FTN, CC, or for C++, capital CC to use the compilers. You just change your progenv module from progenv Cray to progenv GNU or progenv AOCC. Got a little example here. So the most simple of simple examples, let's just try building Hello World. So let's just imagine there I am logged in again. Again, I've done nothing from initially logging in aside from that module list which I ran previously. If I want to build my two programs, hello.f90 is just the simple print hello world program, and then maybe an MPI version of it, both in Fortran. Well, to build it, I would just do ftn hello.f90 -o hello to name the executable hello, and I could then just run that /hello. Because I've logged in and gone straight onto this, that means that progenv cray is loaded. So when I do ftn hello.f90, that means it's running the cray compiler, the HP cray Fortran compiler. If I wanted to use gfortran from the GCC compilers instead, then I would do module swap, and I'd swap out progenv cray and replace it with progenv GNU instead. You'll then get a little message, and that tells you that it's changed the cray mpitch library. You don't need to worry about this. This is part of the sort of magic, I guess, happening in the background. What it's doing is it's swapping the cray mpitch build from the cray compiler version to the GCC version for us, and we don't need to worry about that. It's doing everything in the background automatically. We don't have to worry about it. So then we can just build our hello.f90 again. We'll just use ftn, except this time it's now using gfortran rather than the cray Fortran compiler. If I want to build my MPI program, well, I can just do ftn hello-mpi.f90, and it will build that, and it knows what the mpitch libraries are. It knows how to use them. If I were to be doing it with code using libsci, so maybe I've got some lapack calls in there, it will know how to link that in. It knows how to use lapack. If I wanted to build something with FFTW, I could do a module load FFTW, and the FTN compiler wrapper would again know what FFTW is, and it would know how to link it in to that build. So we always want to use the FTN, CC, and capital CC compiler wrappers for everything. So bearing that in mind, some general build tips. This is only a short slide because I think really using the compiler wrappers does kind of take care of everything. So as long as you make sure that you're using those wrappers, you'll probably always get through to the points you want to be. Really, that means you just need to make sure that whatever build scripts you're using know to use those compiler wrappers rather than to try using, say, GCC. You would say, no, don't use GCC, use CC. So what you may need to do, say, if you're just, say, running a configure, make, install type build, you would maybe just export these as environment variables beforehand. You would say to it, use the CC compiler to compile C code, and use the CC compiler again to compile MPI C code. Something else you want to remember is to always install any software that you build to a spot on the work file system, because remember, home isn't visible on the compute nodes. Home is just a regular file system. The work file system is the high performance file system you want to be using for real work. So you want to make sure that your software is available on the work file system, because otherwise when you try to use it on the compute nodes, you'll find that it can't find it because home isn't mounted there. Something else is to run large and long builds as jobs on the compute nodes. I think we're talking about this on the next slide. And finally, again, the documentation has a lot more information about what you can do. It has information on using different versions of the compilers, how libraries are linked, handy flags you may want to set for better optimization and more. That's all there in the documentation. This slide is kind of like, so login node etiquette is sort of like how much should I tip? This is the how much should I tip part of the Hitchhikers guide. Something important to note is that when you're there working on the login nodes, they are what we call a shared resource, meaning that there are going to be potentially a lot of other people on the same login node as you at the same time as you trying to do their work as well. it is possible to do things which will negatively impact the other users on the node. So we just ask that people sort of don't do too much intensive work on them. And that means that everyone has a pleasant experience when they're trying to do whatever they need to do on the login nodes. So that means that you might want to, you can use them to set up new jobs because you're probably just creating directories, filling them with input files and scripts. You can edit your code, run shorter builds on the login nodes, and you can maybe prepare data by tiling it up, say, to move it elsewhere. What you shouldn't be doing is running anything long. So really kind of what we're talking about here are things like simulations or anything CPU intensive. So this can be, you know, people maybe trying to run simulations or maybe doing very big, very long builds. Anything like that should really be done on the compute nodes or perhaps on the data analysis nodes instead. You can't run in parallel anyway on the login nodes unless you jump through some incredible hoops. So you'll be running in serial. So again, yeah, everything like this should be going on the compute or data analysis nodes, just to make sure that the login nodes aren't bogged down doing anything big, and that the other people on there, and you might be one of those other people, are having a pleasant time getting your work done there. I think finally on this section, just quickly about moving code and data to and from ARCHER2, because you'll probably be wanting to move input data, initial conditions there, or maybe you'll be moving code. Something that's handy to remember is that if you're moving a lot of files, it's often best to create an archive first with either tar or zip. Either is fine. That's because when you're moving lots of files, each file has an overhead on the transfer, whichever protocol you're using. But if you put them all into a single archive, that overhead is just reduced to one file basically. You'll always be sort of pushing data to and pulling from ARCHER2. So you should be trying to SCP or rsync probably, if you're on Linux, macOS, or WSL, from your machine, rather than you'll be doing it from ARCHER2. That will be very difficult and probably impossible. So instead, you'll be sat on your computer and you'll SCP, in this example, local archive.tar from your computer through to login.archer2.ac.uk at whatever destination you give it, or you'll be pulling, in which case you'll say SCP and I want remote archive.tar at this location and work at username at login.archer2.ac.uk and copy it to dot, which is here. If you're using Moba Term on Windows, well, that has a file browser which allows you to drag and drop. So that's very easy. You just copy onto the desktop or from the desktop, whichever. And there are some other tools. We have Globus and Git as well, which can help you get stuff you need onto ARCHER2. Finally, which is good because we've only got about 10 minutes left, I'm going to talk about actually running jobs. So we have a tool called Slurm. That's the simple Linux utility for resource management, but Slurm, the funny name Slurm, is much more common to use, is what we use to actually do things on the compute and data analysis nodes. So you'll create a job. They go on into a queue, which is managed by a Slurm. That will schedule the jobs. And then once they get to the top of the queue, and once the resources that they need are available, Slurm will then run it for you. So jobs are kind of two parts. One part is the resource that's needed, which really comes down to how many nodes are needed for the job and how long will those nodes be needed for the job, and then what to actually do for the job, what is actually to be done. Most users, a vast majority, I think, will run jobs by submitting job scripts to Slurm. And that includes all this information, what resources are needed, and what to do with those resources. But you can also run jobs interactively, which means you actually go and sit on a compute node and run the commands yourself in the command line in your terminal. That can be useful for small tests and debugging, but if you're running, a 48-hour CAS-step job, say, you probably want to just do that as a job script. Once the job is finished, you'll be charged for it. So it will work out what resources were used, and then it will take them away from your budget. Those resources are measured in what we call CUs, where 1 CU equals 1 node hour. This might be slightly strange if you've not come across this before. That means that 1 node for 2 hours means that you've used 2 CUs, because that's 2 node hours. Or 2 nodes for 1 hour is exactly the same, 2 CUs again. So you work out how many nodes multiplied by how long were they in use for the number of node hours, and that's equivalent to the CU cost of the job. To see what resources you actually have, you can again go to your page in the safe for your account, and there you'll see 1 or possibly more budgets listed and their resources in CUs. And you can always come back to this page and see what's actually available to you. Those budgets will have names. So I'm on the Z19 project. That means I've got access to the Z19 budget. That means I should tell Slurm to charge the Z19. Some people will have extra budgets available if they're on sub-projects, say. They'll all be listed on that same page. Every budget that you have access to will be listed. What does a job script actually look like then? Well, it's kind of in 2 parts. We've got the first part here with all of these S batches. Well, there's actually the first part is the shebang at the top, /bin/bash, says that this script is to be run as a bash script. Then we've got all of these #sbatch lines. These are the commands which go to Slurm. So these #sbatches are Slurm directives that tell Slurm what resources are needed for the job. So first of all, job name, kind of self-explanatory. Then you can see nodes equals 8 means we want 8 nodes. We want to run 128 MPI tasks on each node, each of those 8 nodes. So that's quite a lot overall. We want to allocate 1 CPU core to each task. We want our job to run for a maximum of 10 minutes. Partition and QoS, I'll talk about next slide. And account Z19, this accounts equals Z19 is what says that for me, if I were to run this job, says it should be charged the Z19 account. The second part of the job script is essentially just a regular bash script. First of all, this is going to run VASP, so I'm going to module load VASP version 5, because if I didn't do this, it wouldn't know what VASP is. It's just like when you're working on a login node. If you don't module load the software you want to use, then it won't be available, so I have to module load it first. The export OMP num threads, most people here won't really need to worry about that, that just means that in this case, we'll prevent threading. And then finally, srun is the command used to do a parallel launch, in this case of the VASP _ standard executable. So this is what actually starts VASP running in parallel with 128 tasks across 8 nodes. As for what the partition and QoS mean, the partition is how we tell Slurm which group of nodes we want to use to run the job on. There are 3 really that we need to worry about. Standard is what we'll be using probably most of the time. This contains all of the compute nodes, both standard memory and high memory, but it prefers the standard memory. If you are running something which really does need the high memory nodes, you need those 512 gigabytes of memory per node rather than 256, then you would say, I want to use the high mem partition instead. Finally, if you wanted to use the data analysis nodes instead, you would ask to run a job on the serial partition. Then the QoS, that stands for quality of service, that defines the limits for the job. So how long, how many nodes, how many jobs are you allowed to run? This is all part of keeping it fair. So part of Slurm's job is to keep things fair among the many people using the system. So we say no one person is allowed to use everything if they're just running in the standard QoS. That means you can run up to 1024 node jobs for up to 24 hours, but at the same time, you can only have 64 jobs in the queue in total. You can only have 16 running at any one time, and you can only use up to 1024 nodes at once. There are many QoSs actually, depending on what you're trying to do. If you need to look at those, I would say take a quick look at the QoS section in the documentation. You'd write that job script, that VASP job that I gave a couple of slides ago. You'd just make it a simple text file. You'd edit that with Vim, say. Remembering again, everything should go on the work file system. And then to actually get that running, you would do sbatch space and then the name of your job script. Once you do that, that job will go into the queue. You'll be told the job's ID. You can always check your jobs, see what you have in the queue at the moment with this sq-u command, and then you give it your username, or you can just use $user. And then you would go along and see all the details of all your jobs currently in the queue. And if you ever need to cancel a job, you can do scancel and then give it a job ID. So I'm aware I'm overrunning here as it's almost 4 o'clock. I think this should be, are we okay to carry on, Krivine? I'm happy to carry on as long as needed. I've only got a few more slides left.
I think we're probably okay to carry on.
Okay, this will be recorded, I guess, for people if people need to head off for the last little bit. We have only got 3 more slides. So yeah, so what you actually do in these jobs is entirely up to you. I showed you that very basic VASP example, but what you actually do once you've requested your resources is entirely up to you. It's limited really only by what Bash is able to do. So you can run pure MPI jobs over however many nodes. You can run with hybrid jobs with MPI and OpenMP. Something some people do is they maybe want to run jobs which don't use a whole node, but you can instead run on fractions of a node. So in the example here is 4 simulations, each using 32 cores on one node. So you'd still be using all 128 cores on the node, but each group of 32 cores would be running a different simulation. Or maybe you need to run the same thing several times, but with slightly different input data or different parameters being passed. So you could maybe create a job array. That means you would write one job script and submit it as a job array, and each subjob would deal with different arguments into that simulation. And as I mentioned, you can run interactive jobs, which is great if you're doing debug work. Next step, so this is really just to finish things off. The main ARCHER2 website is a useful stop if you want to see about getting access or taking the driving test. There's a calendar there of upcoming training. I'll also talk about that on the next slide just to finish things. And also, if you're maybe trying to log in and finding, and you've logged in before but find that you aren't able to now, the current service status is there, so you can go there quickly to check out, is the service up, has it maybe run into issues. The documentation also covers more about basically everything you can do on the system, more than we have time for here, and I'm already overrunning. And if you run into issues, please contact the service desk. Again, we're friendly people, will be very happy to help you out if you're running into any problems. You can just send us an email at support@archer2.ac.uk. Upcoming training, if you want to take anything further, if there's anything you want to get yourself ready for work you're planning on doing on the system, we run lots of training just over the next month. I know we've got at least three courses coming up for ARCHER2 for package users. So this is if you're one of those people who really just wants to jump on and start running VASP simulations or the like. You could take this course on the 10th of March, that's online. Software carpentry, we're running in person at Heriot Watt. That has some information on running Bash scripts and using Python, helping you get going there. And if you are interested in learning about message passing programming with MPI, that's a 3-day course we're running online towards the end of March. And we also have some self-service courses always available. And I think I'll end that at that point so that people are able to ask any questions if they have anything to ask. And I'll just say thanks for listening. Hope you found it useful.
Thanks very much, William. And yes, as he says, if anyone has any questions, you can either type them in the chat or you can click the raise hand button. And I'll answer David Gilbert's question. These slides, they will, I believe, be available on the ARCHER2 website after the talk. I think they usually go up in the next couple of days following the talk.
Hi, so we've got a question from Nikki. Is there a Globus online endpoint for ARCHER2? That's actually something I'm not entirely certain of. I was under the impression it was, but if it isn't, I know it's something that enough people are interested in, so I imagine if it isn't there just now, it should be soon. I'm sorry I can't tell you any more on that. I'm not a Globus user myself. When we ask, class of ARCHER2 has singularity? Yes, it does. It has a singularity build. It can be a little tricky to use, I think, if you're planning on running with the Cray mpitch, but it can be done. We have some template scripts and a good amount of documentation on using singularity on the documentation website, and I've managed to use it now with 3 different types of simulation, so it can be done. I've grabbed, there are a couple of things. I've just grabbed containers from Docker Hub with singularity written job scripts based on the template that we have on the website and got it to work straight away. So the job scripts look a little messy, but they do work. It's just a matter of binding in ARCHER2's MPI into the container so that the application in the container can use it, but it actually works really well. I think we do also run, actually a singularity course as well. I don't know if that's anywhere in the upcoming courses for the next month or so, but we do run a singularity course, so maybe that'll be of interest to you. Okay, great, you're welcome.
Does anyone else have any questions they'd like to ask William?
Claire's just put the link to the container course there, fantastic. That was the last one, okay. But still, yeah, so we keep all the material for past courses and we record them, as Claire's just said, so you can go back and basically work through them yourselves if you would like to, but all the material there is available on the website.
Okay, great. It seems like there aren't any more questions, so thank you very much, William, for giving the talk. That was great, and thank you all for coming.
Okay, thanks everyone. I hope you found it useful. Have a good day now.